Hey mathematicians, we are talking about direct variation today. It is going to be building off of what we talked about yesterday with proportional and non-proportional examples of functions using t-tables, graphs, and equations. So what we're going to talk about today is direct variation. And direct variation is a specific type of equation that goes through the origin. It's written as y equals a number times x, and there's going to be a consistent rate. Okay, so when I'm looking at this, some things that I need you to make sure is that you've got y equals kx. That's going to be the equation. Okay, I want you to know that the line passes through the origin. That's important. Okay, some examples: the numbers of hours you work and the amount of your paycheck. If you don't work, you don't get paid, right? The amount of gasoline you're going to use. If you don't drive your car, you're not going to be using any gasoline. And so looking at those different examples where if it's zero, it's zero. Okay. So what we can do is we're going to write a direct variation function. We're going to teach you how to write equations and solve equations where y equals kx. Okay. And so we're going to talk through that process. We've got some examples for you, and then we're going to work you through it. Okay. So when we look at this particular thing, the amount of spring that a spring stretches varies directly. Okay. And so what we mean by varies directly means that as one increases, the other increases. Okay. The spring is stretched 10 centimeters by a weight of 8 kilograms. Okay. It stretches 8 centimeters as a weight of 8 kilograms. So in this case, the stretch depends on the weight. So I wrote y and x there. Y is the dependent variable, x is the independent variable. We talked about that a few months ago, so we got to pull that back into our conversation, okay? The stretch depends on the weight. So the y is the stretch, the x is the weight, okay? So my ordered pair other than 0, 0 is going to be 8, 10. Okay. Right? Because the weight is x, the stretch is 10. Now, substitute the point into y equals kx. Okay. So when I do that, I'm going to substitute 10 in for y, k stays there, and x is 8. So I'm substituting those values in. The next step is to solve for k. So again, I identified that my dependent variable is the stretch, my independent is the weight. I filled those values in. I substituted them in for x and y, and now I'm going to solve for k. Pulling my equation solving skills back, 5/4 equals k. I just solved for it. And my last step is to write the equation. Y equals 5/4, not x, not k, it's going to be x. Y equals 5/4 x. That's my equation, okay? So we're going to go through some examples of that, practice that with you, and then solve it out. All right, so here we go. Okay. So we're going to suppose that y varies directly as x, okay? So the first thing I'm going to do is I'm going to write down y equals kx, okay? Next, step 2. I need to come up with a point other than 0, 0. And that point is going to be -3, 9. Because that's what it's giving me, -3, 9. The next step, okay, so I got my equation, y equals kx. I got my other ordered pair, which is -3, 9. And now I'm going to substitute those values in. Y is 9. K stays that way. And x is -3. All right, I substituted in my values. I have my x, and my y, just like it told me right here. I'm going to divide both sides by -3. So k equals -3. So my constant of variation, my rate of change, is k equals -3. So when it says write a direct variation equation that relates them, that's going to be y equals -3x. So my value of k goes in for x. This is a two-part question. This is one part. My second part says solve for x when y is 15. Okay, so I'm going to put y is 15 in for y. So 15 equals -3x. I'm going to divide by -3. So x is equal to -5. So two parts to the question. Here's one of my answers. Y equals -3x. Here's my other answer. -5 equals x. Okay. Let's try the next question. I'm going to switch up my colors here. First thing I'm going to do, write my formula. Y equals kx. Okay. Suppose y varies directly at x. Y equals kx. Okay. It says that y is -10 and x is 4. So I'm going to substitute those back into my equation. So -10 equals k times 4. Substituting in what I know. Now I need to solve my equation. Divide both sides by 4. That's how you undo multiplication. So k is equal to -5 halves. Now, when you take -5 halves, that's your k. So the first part of the question is y equals -5 halves x. That's the first part of what the question's asking you to do. It's a lot of steps to get there. I understand that. It's a lot of steps, but that's what we need to do. My next step then says, what is x when y is 20? So I'm going to put 20 in for y, and I'm going to solve my equation. All right, so now I have an equation, one step. I need to multiply both sides by the reciprocal. That's how I'm choosing to solve it. So x is equal to -8. That's the second answer to my question. Okay. All right, we've got one more to go. All right, and this is meant to be a review from what we did in class. So hopefully, you know, if you still got questions, that is fantastic. I mean, that's fine. Make sure you ask them though. Okay. I need you really to be asking those questions. So let's go ahead with the next one. All right, here we go. So suppose y varies directly at x. So we're going to start by writing our equation. Y equals kx. Okay. Now we know that y is 15, x is 30. So I'm going to put 15 in for y, 30 in for x, and I'm going to solve my equation. So I'm going to divide both sides by 30. So 1/2 equals k. Now the next step is to put that first answer, write that direct variation equation, y equals 1/2 x. That's the first answer. Now the next answer says solve for y when x is 5. So solve for y when x is 5. So y equals 1/2 times 5. Okay, so y equals 5 halves. That's my second answer. All right. And that's how you find direct variation. Again, we'll do more time in class and check in on any of those Wednesdays too to see if you need some extra help. Okay, whatever you need, reach out. We want to make sure you're all prepared and ready for your assessment, okay? Have a great day. I'm going to be signing off for right now. Take care. Bye-bye.